Alright, in this lesson we are going to be talking about algebra properties, so linking those to what we're doing with reasoning and using our deductive reasoning with those properties to write our first proof. So let's get started. Deductive reasoning. We talked about this before, is a process of reasoning logically from given facts to a conclusion. So let's look at a little refresher of our algebra properties. Some of our algebra properties. Let's start with the addition property. It says if A equals B, then A plus C equals B plus C. Okay, so in other words, if we add the same number to both sides of the equation, then the equation still holds true. So let's throw some numbers in here. Maybe these will work, or we'll click better if we have some numbers. So let's let A equal 5. Let's let B equal 5 as well, and then let's give a value of C to be 2. Okay, so we're going to use these for each of our properties here, and then let's plug in numbers. Make sure this, we want to kind of check and make sure these properties that Mr. Flory is telling you are indeed true. You don't always have to take my word for it. Okay, so let's plug them in. A is 5, B is 5 equals 5, that's true. If that's true, then, notice we've got a conditional statement, then they're saying 5 plus C in this case is 2, could be any number though, and B is 5 plus 2. Now, is that true? 5 plus 2, is that 5 plus 2? Yeah, they're both 7, right? So 7 equals 7. Alright, so that's the addition property. Subtraction property says almost the same thing, except instead of adding the same number to both sides, we can subtract the same number to both sides. So if we have 5 minus 2, that should be the same as 5 minus 2. 5 minus 2 is 3, 5 minus 2 is 3. Makes sense, right? Okay, so these are the properties that you've been using to solve equations. Okay, they're just kind of spelled out, they're given as actual algebra properties. Okay, multiplication property says that if we have one number or one variable, one left side of an equation equal to the right side of the equation, then if we multiply both sides of the equations by the same number, we should still get a true equation. Okay, so 5 still equals 5. Let's see, 5 times 2, does that equal 5 times 2? 5 times 2 is 10. 5 times 2 is 10. Yeah, of course it does. So, multiplication property. Multiply the same number on both sides of the equation, it'll stay equal. Alright, division property. Same thing except dividing. So 5 divided by 2 is equal to 5 divided by that same number 2. 5 over 2 is the same as 5 over 2. Okay, 2.5, 2.5. That is true. Alright, substitution property says that if A equals B, then B can replace A in any expression. So we know A and B are both 5. So let's say we have some expression 7A plus 3A squared. Alright, this says that if, let's go back there. Let's say that, let me get rid of that. Let's say if we take our A's and replace B wherever we see an A, as long as A equals B, then that's the substitution property. So if we plug in a 5, 7, that's a 7 times 5 plus 3 times 5 squared equals 7 times, and then B is also 5 plus 3 times 5 squared. And of course, we're not going to work those out, but of course they'll also be true. Okay, one more to the distributive property. Been using this for a while. If you have some number times the sum of two numbers in parentheses, then you can distribute that coefficient out front. So if we have 5 times 5 plus 2, then that's the same thing as distributing that 5. So 5 times 5 plus 5 times 2. And of course we can simplify that to 25 plus 10, which is 35. Okay, so distributive properties. So just a little review of our algebra properties. All right, let's look at an example of how we're going to use this with deductive reasoning in geometry. So let's say we're given that the measure of angle AOC is 140 degrees. All right, we've got a nice picture here. AOC, the big angle, is 140 degrees. We're asked to solve for x and justify each step. All right, so here's the important part. We're asked to justify each step. So we're gonna work this out. We're gonna solve for x, but we're gonna give a reason why we can go from step to step. Okay, so in a sense we're gonna have a column where we've got each of our statements, which we're used to writing when we solve an equation. And then we're also going to have a column where we have the reason that we can give that statement. Okay, we're just going to kind of organize our thoughts and reason deductively from step to step. So, first statement, let's start with what we're given. We're given that the measure of angle AOC is 140 degrees. Okay, and the reason for that is just that it's given to us. Alright, and I might number these. That's one. First statement, first reason. Okay, if we go on to our second statement, well, AOC, if you notice from the diagram, is made up of this slice here, angle AOB, and this slice here, angle AOC. So using our angle addition property, or postulate, we can say that the measure of angle AOB plus the measure of angle BOC equals the measure of the big angle AOC. And the reason we can give that, like I said, is the angle addition postulate that we learned back in Unit 1. Alright, so now where can we go from there? We're still, again, our goal is to solve for x. How about we substitute in values into this equation? So we know from our diagram that the measure of angle AOB is some number x. So let's substitute that x in. Measure of angle BOC is expression 2x plus 11, so let's plug that in. And what do we know about the measure of angle AOC? Well, we're given that the measure of angle AOC is 140, so we can substitute 140 in for the measure of angle AOC. And what's our reason? Well, it's the substitution property. Okay, so now we've got an equation with one variable. Now we can go through and we can solve. Okay, but again, we're going to give a reason for each step. First thing I see, we've got like terms. X plus 2x is 3x plus 11 equals 140. And the reason we can put for that is simplify, or we'll put combine like terms. Alright, we're doing good. Let's go to step 5. If we want to get this x by itself, then we need to subtract that 11 from both sides. So our next step is going to show 3x equals 129. And we can do that because of the subtraction property. Says we can subtract the same number from both sides, and it won't affect the truth of our statement. Okay, we're almost there. Again, our goal is to get this x by itself. The last thing we need to do is divide both sides by 3. So divided by 3, divided by 3. And what we get is x equals 43. And the reason we can go from here to here is that division property. Okay, so we got our x. Did we solve what we were asked to solve? Yep, so we solved for x and we justified each step. So this is our first proof. Okay, so proofs in geometry are where we deductively reason from given information down to something that we're asked to prove. Okay, given a reason for each statement. All right, great. Pat yourself on the back. Your first proof. All right, but don't congratulate yourself too long. Let's go to example number 2. Example number 2 says AC equals 21. We want to solve for y. Okay, so we're given this figure here. What I'd like you to do in your notes is jot down this given information, this diagram, and then do the same thing we did on example 1, where you have a column of a statement, and a reason, and go step by step from your given information. Remember, start with your given, use your diagram to reason down to solve for y. Okay, let's look at some other properties having to do with congruence in geometry. Okay, the first one is the reflexive property. Reflexive property says that if segment AB is congruent to segment AB, no, not if, it says the segment AB is congruent to segment AB, or angle A is congruent to angle A. Those are two examples. If we look at how those might look, so let's say segment AB. So let's say that this is segment AB. Now, is this segment congruent to itself? Yeah, it's got the same measure, same size, same shape, so it's congruent to itself. That's all the reflexive property says, that any figure is congruent to itself. Okay, if we have angle A, let's say this is angle A, then yeah, angle A is congruent to itself. It has the same measure, same shape as itself. Okay, the symmetric property says that if segment AB is congruent to segment CD, so let's make segment CD, remember those tick marks mean that it's congruent to. Okay, so if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. So the symmetry of it says that you can just kind of flip around the congruent statement. Doesn't matter the order, front to back or back to front. Okay, same thing with angles. We could take and make an angle B. So if this is angle B here, this is angle A up here, then if angle A is congruent to angle B, then angle B is congruent to angle A. That's our symmetric property. Alright, our transitive property. This is a good one. It says if if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then, notice these are all in conditional statements, then segment AB this guy here is congruent to segment EF, this guy here. Alright, so if we have two statements in our hypothesis, they're both true, and we've got this same segment in this case. Notice this is a lot like the law of syllogism that we talked about in the previous lesson. Law of syllogism is an application of this transitive property. Okay, or in algebra you may have learned it as if A equals B and B equals C, then A equals C. Okay, same thing. You can do it with angles, segments, you can do it with congruence as well as equal symbols. Alright, a couple quick examples in your notes. In addition to example number 2, I would like for you to jot these down and then name the property of equality or congruence that's illustrated in each of these.